In this video, we're going to continue solving one-step equations, but this time we're going to learn the multiplication and division properties of equality. The multiplication property of equality says that if A equals B, you can multiply some quantity, like C, to both sides of the equation and the equation will still be true. So just like we saw for our addition and subtraction properties of equality, we start out with two numbers that are equal, like A and B, or we can say A is equal to 5, which is equal to B, so they're all equal to B, so you have 5 equals 5, and you can multiply some number like C, so we're going to say C is equal to 3 to both sides and it'll still be the same. So we can say 5 times 3 equals 5 times 3, which is 15 equals 15. So we know that the multiplication property of equality is true. So for this example, we're going to look at x over 4 equals 12. I'll just rewrite this because the formatting seems to be a little bit weird in the video. So x over 4 equals 12. So remember, our goal is to get x all by itself on one side, and that's what we say when the equation is finally solved. We have x on one side all by itself. So in order to get rid of this 4, what you can do is multiply both sides by 4. So multiply this side by 4, or 4 over 1 if that makes it easier for you to see, and multiply this side by 4, or 4 over 1. So here, if you multiply straight across on the left side, you get 4x over 4 equals 12 times 4, which is 48. So here, 4 over 4, remember you can do multiplication and division in any order, so we're going to do 1/4 times 4. 4 divided by 4 will give you 1, so you just end up with 1x equals 48, or just x equals 48. So just to elaborate on this little part a bit, we can say, you could have it in many different ways. You can show it as x, or x over 1, multiplied by 4 over 1, multiplied by 1 over 4. So remember that the order that you do multiplication doesn't matter, and that comes from our associative and commutative properties of multiplication. So here we have x over 1, 4 over 1, and 1 over 4. So this is the same as this part we had here, which is 4 over 1, so that's there. Then we have x over 4, which is the same as x over 1 multiplied by 1 over 4. So then 4 over 1 times 1 over 4, these would cancel each other out, so you just have that x on one side. Our division property of equality says that if A equals B, you can divide some quantity, like C, from both sides of the equation and the equation will still be true. So we have A equals B, and we're going to say A equals B, which equals, we'll just say 6 this time. And we can divide both sides by a number C. Let's say C is 2. So we have A divided by C, so A is going to equal 6, divided by C, which is 2, is going to equal B divided by C. So A and B are equal, so B is also 6, divided by 2, because 2 is C. So we have 6 divided by 2 is 3, equals 6 divided by 2, which is 3. So that's true. So now we want to solve this equation down here, and we want to get this x alone. So in order to get the x alone, we have to get rid of that 3. The only way to get rid of that 3 is to divide both sides by 3. So we can say this side divided by 3, and these would cancel out, so 3 divided by 3 is 1, so you have just 1x, or x. And then you do 57 divided by 3, because remember you have to do it to both sides. And 57 divided by 3 is 19. So that's your final answer. Just like the previous video, you may want to go ahead and pause right now and practice some of these on your own. Then we can go over them, and anything you got wrong you can correct. For our first example, in order to get y alone, we're going to divide both sides by -6. So it's okay to take that negative and put it with your 6. So we have -6 divided by -6, which will give you just y on the left side, and 13 divided by -6. So we don't know what 13 divided by -6 is without a calculator, and it's absolutely okay to leave it as an improper fraction. So you can't simplify 13 over 6 any farther, so we're going to say -13 over 6. So it doesn't matter whether or not you put the negative sign on the numerator or the denominator, so I decided to put it in the numerator. Most times you'll see it in the numerator. So for this next equation, I'm going to go ahead and write it on the side so we have some room. We have c over negative 2 equals negative 7. So in order to get rid of negative 2 on the left side, so we just have c, you can multiply both sides by negative 2. So if we multiply this side by negative 2, or negative 2 over 1, and this side by negative 2, you would get negative 2c over negative 2, these would cancel out to give you just c, is equal to negative 7 times 2. So 7 times 2 is 14, and since there are two negative signs, then it's equal to a positive number. So we have c equals 14. Our next example is a little bit tricky. So we have negative x equals 14. So you might be able to reason that one out in your head, but if you want to try it using the multiplication and division properties of equality, I would recommend it. So if you're trying to get rid of a negative sign in x, remember that negative x, or even just 1x that's positive, has a coefficient of 1 in front of it. So we have negative 1x equals 14. That makes it a little bit more clear, and you can divide both sides by negative 1 to get x equals 14 divided by negative 1, so 14 divided by 1 would just be 14. But remember, a positive number divided by a negative number will be negative. So we have negative 14. Our last example is a little bit tricky as well, just because it looks different from the others. But you do the same thing where you try to get z by itself, divide both sides by 7, and you get 7 over 7 here, so this becomes just 1. And you get 7 over 7 here, and that becomes 1. So you have 1 on the left side equals 1z, or just z. So z is equal to 1.